We're so excited about today's session. As more and more of our customers adopt the cloud, some of them more mature, some of them still early days. As no matter where you are in the journey, if you're dealing with massive workloads, we're talking about terabytes or even petabytes of data, the common question a lot of our customers ask is, how do we cut the cost, right? So cost optimization is a big thing. In today's session, we're going to talk about Yahoo's journey of moving their ad platform into AWS and how they cost optimize their workloads using ElastiCache. Today with me, we have Senior Principal Software Engineer from Yahoo, Maulik Shah. And from AWS side, I'm really honored and excited to share the stage with General Manager of AWS in-memory database services, Itai Meos. And I'm Siva Kartori, Worldwide Specialist SA for in-memory databases. As you know, we now have two databases in the in-memory categories, Amazon ElastiCache and Amazon MemoryDB for Redis. So for the agenda today, we're going to kick this off with Maulik talking about Yahoo's use case and how they solved a typical big data problem using Amazon ElastiCache, and how they further cost optimize the workload using data tiering. And since today's session is all about cost optimization, we're going to deep dive into data tiering with ElastiCache. And towards the later part of the session, we're going to briefly cover our other in-memory database service, Amazon MemoryDB for Redis, and then close it off with all the latest and the greatest new features that we launched with Amazon ElastiCache. With that said, I want to turn this over to Maulik for Yahoo's use case.
Thanks, Siva. Hello, everyone. My name is Maulik Shah. I'm a Senior Principal Software Engineer at Yahoo. I work within our Ads, Data, and Common Services organization, and I help to architect, design, and implement big data processing solutions for our ad platforms. In this session, I'm going to show you a data processing challenge we faced, how we solved it using ElastiCache, and discuss how we cost optimize the solution with data tiering feature in ElastiCache. I want to start with a brief introduction to who we are as Yahoo. We connect with hundreds of millions of users around the world with sites and apps like Yahoo Mail, Yahoo Sports, Yahoo Finance, and many more. We also connect brands with publishers and their audiences on our ad platform as part of Yahoo AdTech business. Since this talk is focused on Yahoo ad platform use case, let me set up a context of a talk with an overview of advertising ecosystem at Yahoo. Our ad business primarily provides two advertising solutions, DSP, which stands for Demand Side Platform, and SSP, which stands for Supply Side Platform. DSP is advertisers-facing solution, while SSP is publishers-facing solution. Publishers can be Yahoo's owned and operated media properties, or they can be our third-party supply partners. Publishers have consumers or end users who consume their content, and these consumers are the source of most of our business and data signals. Consumers connect with us from many different devices. For example, smartphone, tablet, connected TV, desktop, digital out of home, and few others. Let me show you a typical request flow when a consumer visits publisher content. A user like you and me visits a publisher webpage, for example, yahoo.com, which makes an ad request to our supply-side platform. Our supply-side platform ad server logs this request in form of an ad request element. It then starts an auction process and sends out the bid request to multiple demand-side platforms. One such request lands on Yahoo's own demand-side platform. Our DSP ad server performs ad selection process, finds the best matching ad for the user, and returns the response back to our SSP. Once our SSP receives responses from multiple DSPs, it closes an auction process by selecting a winning ad and a winning DSP. All the bidding and winning information is logged in form of an ad auction ad event. A winning DSP is notified, and a winning ad is sent to the user who requested it. Now, user can view this ad along with the content, which results in an ad impression event being logged by ad server. And if user clicks on an ad, it results in an ad click event being logged by ad server. All the ad events are transported by data transport system, processed by ad event data processing system, and summarized by reporting and finance system for our customers. Let's take a look at scale of the ad events and a critical operation that needs to happen inside ad event data processing system. Our ad server generates about 320 billion events per day. Ad request and ad auction events are high volume events with data size of 400 to 800 GB every 5 minutes. On the other hand, ad impression and ad click events are lower volume events with data size of 10 to 100 GB every 5 minutes. If we take a look at ad event timeline for a given user session, ad request and ad auction event are logged seconds to minutes apart, while ad auction and ad impression or click events are logged minutes up to 4 hours apart. For various reporting and analytics use cases, ad auction event needs information from request event, and similarly, impression and click events need information from both request as well as auction events. And since these ad events are logged at different intervals, challenge is to perform join operation across these ad events at scale. One might think that this is a typical big data join problem. Events can be transported to a data lake and can be joined using join operators in framework like Apache Spark. Let me take an example of ad impression event join with ad auction event. We know the size of impression data for 5 minutes is about 100 GB. We also know the size of auction data for 5 minutes is about 600 GB. If we join these two 5 minutes data sets within Spark, it will perform well with reasonable number of resources. But if you recall from the previous slide, impression and auction event may be logged 4 hours apart. As a result, 5 minutes of impression data needs to be joined with 4 hours of auction data, which is 30 terabytes. We now need to scan 48 times more data set and shuffle it across the network in order to perform the join. Not only that, we need to rescan most of the 30 terabyte of data during next 5 minutes of impression data processing. This is very resource intensive and non-performant. We need a better solution. Better solution would be to use distributed key value stores. Distributed key value stores support random lookups, which can help us locate the joining event very quickly. It also helps us avoid repeated scan of the same data sets again. And most importantly, key value stores are suitable to work with both batch as well as streaming data processing workloads. Let's take a look at our use case and see how we can use key value stores to perform our join operations. First, a request event would be loaded into key value store. A minute later, when ad auction event arrives, we will retrieve a request event using request ID and perform an auction join. The join auction event is then stored back into key value store. An hour later, when ad impression event arrives, we can retrieve join auction event that we previously stored and perform an impression join. We can repeat the same process for ad click event as well. Here are some of the key value store solutions that we considered. We started off with DynamoDB. DynamoDB is a serverless and fully managed service. It provides durability and persistent guarantees, which was not really fully required for our use case. Additionally, the cost model of DynamoDB is based on read and write requests as well as payload size. When we calculated the cost for our use case, it was quite expensive. So we decided to start considering other options. Next option we considered was HBase. Amazon EMR provides HBase on top of HDFS as well as S3. We had good experience working with HBase from our on-prem streaming and batch data processing workload. But on AWS, we did not want to maintain a very large HBase cluster footprint and perform regular maintenance tasks like OS updates and performance tuning. We really needed a fully managed service. We then considered Amazon ElastiCache. ElastiCache is a fully managed service. It can serve as an in-memory key value store. It supported Redis engine, which we were familiar with from our on-prem streaming data processing workload. And ElastiCache also provided very low latency read and write operations with sub-millisecond response time. So we thought it would best suit our needs because our add events would need to be stored in memory only for about 4 hours to perform our join operations. This is the setup that we started prototyping with. We used Redis engine with node type of R6G 2x large, which came with about 52 GB RAM. We enabled the cluster mode and configured no eviction for the keys and encryption in flight as well as at rest. In order to communicate with the cluster, we used Lattice client. We then loaded about 1 hour of auction data into our ElastiCache cluster, which required about 150 nodes. We measured the performance of our 5 minutes of impression data operations, and we observed that our join operations finished within 5 to 10 minutes based on the number of processing resources that we allocated. In terms of cluster sizing, we calculated that for our full production workload, we'll need about 650 nodes to cache about 30 terabyte of data. Now, caching all the data sets in memory results in a very large cluster footprint and thus very high cost for our use case. In order to optimize for the cost, we started gathering join heuristics. We calculated the time difference between 2 joining events and plotted a histogram of event counts by the minute bucket. As you can see in a graph, 95% of event joins within 1 hour of window, and rest of them joins within 4 hours of window, which means that most of our join operations only need about 25% of memory or cache, and very small fraction of joins need 3 times more memory or cache. So the question was, can we offload these 3 hours of cold data to a more cost-effective disk-based storage without sacrificing our application performance? We started thinking of solutions. One solution we thought of was side caching. 1 hour of data can be loaded in ElastiCache. In parallel, load all 4 hours of data in HBase cluster, which is configured with less memory, backed by HDFS and S3. But this would be more complex setup, more complex read and write logic, and require more maintenance tasks as well. We decided not to pursue this option. Meanwhile, Amazon team reached out to us, ElastiCache team reached out to us to see if we are interested to be a beta customer for a new feature called data tiering. We were very excited to test this feature because this was exactly what we were looking for. Data tiering feature was supported on a node type with large SSDs. In our case, we were provided node R6GD 2x large, which came with about 52 GB RAM and about 200 GB SSDs. We onboarded onto beta cluster, and we started performance testing our full production workload. In terms of cluster sizing, since we have 4 times more storage capacity thanks to SSDs, our node requirement went down from 650 nodes to 150 nodes. This is a 4x reduction in footprint of our cluster, and effectively 50% reduction in cost of operating our cluster. Our join operations still finish in about 5 to 10 minutes, same as before, with about same number of processing resources without impacting our customer SLAs. We can say that data tiering feature enabled us to productize our solution in a cost-effective way with a single service and without additional complexities. Here's the final end-to-end architecture as it stands in production today. Our ad server logs the ad events, which are transported by AWS Kinesis and deposited into our S3 data lake. We have an EMR stack which ingests these data sets from S3, performs the join operations using ElastiCache, and publishes the join data set back into our S3 data lake. The join data set is also registered with AWS Glue for data discovery. And our customers can query this join data set from Athena, or they can directly ingest this data set from S3. We all know that no system can function without effective metrics and monitoring. We actively monitor many standard ElastiCache metrics, and we categorize them in two groups: metrics for alerting and scale-out operations, and metrics that help us monitor issues during backlog processing or during peak traffic. During normal data processing, if engine CPU or byte use for cache goes beyond 70 to 80%, we perform scale-out operation. And during backlog processing, we monitor metrics like get and set latencies, current and new connections, along with engine CPU, to see if we need to perform scale-out operation or throttle our data processing workload. Let me show you one example metrics from our current production ElastiCache cluster. This graph shows storage metrics for our auction data. Total size of auction data in cluster is about 50 terabyte. Cluster has two tiers, SSD and memory. Memory tier has about 10 terabyte of data, and SSD tier has 40 terabyte of data. Since most of our data set is stored in SSD tier, this demonstrates how we are able to expand our storage capacity and cost optimize our cluster. Optimizing the cost was a great win, and every win comes with learnings. Let me share some of this learning with you. After about a week of deployment in production, we had an issue with our EMR cluster, which led to a backlog in our data processing. Many of our jobs started retrying and established many new connections with our ElastiCache cluster. In this process, we managed to get our ElastiCache cluster very busy, which impacted our normal data processing. The fix was to reduce the number of connections to our ElastiCache cluster by sharing connection between threads. The key lesson that we learned here was to have persistent connection to the ElastiCache cluster or minimize them by sharing connection between threads or use connection pooling. Another lesson we learned was to implement exponential backoff with retries. That's a standard procedure for engineers. Like any solution, there is always an opportunity to optimize further. In future, we want to further optimize our cost by reducing the size of the payload that we store in ElastiCache cluster. We also want to implement auto-scaling feature for data tiering. Additionally, we want to migrate our Redis-based on-prem data streaming workload onto AWS to work with ElastiCache. Let me recap what we have covered so far. We started with advertising ecosystem overview. We then introduced our joint problem, which we solved with ElastiCache. And finally, you learned how we reduced our cost of ElastiCache cluster by about 50% using data tiering feature. With that, I want to thank you all for your interest in our use case. If you have any further comments or questions, please feel free to meet me outside the hall after the talk. Back to you, Siva.
Thank you, Maulik. Thanks so much for sharing Yahoo's use case. This is yet another example of how AWS constantly innovates on behalf of our customers. Staggering 70 to 80% of all the product features that we release every single year is based on direct customer feedback. Data tiering is one such example. We are super proud of our product team to reach out to Yahoo just about the right time to take a look at their use case and see how they can not only solve the big data challenge, but also cost optimize the workloads by using data tiering. So let's dive a little bit more deeper into what data tiering is. Data tiering is the ability to expand the storage capacity of ElastiCache clusters by independently or transparently moving the data from memory to a locally attached SSDs. So if your ElastiCache cluster nodes reach max memory, ElastiCache will then start moving the data from memory to the disk. The way we choose which data to move is based on an LRU or a least recently used algorithm. ElastiCache keeps track of last access times of all the items in memory. So if your memory fills up, ElastiCache will move the items with the longest LRU times to the disk. So in the later times, if you need to access the items back again, data tiering engine will then push the items back into memory for access. With data tiering, we are now providing a new price performance option for our customers. SSDs definitely have higher latencies, but they provide significant cost benefits compared to memory. If your application can tolerate slightly higher latencies, data tiering can definitely provide good cost options for you. Now, if you want to ask me, all right, so can I move the entire data into SSDs? Just keep tiny little bit, maybe 1% in memory. That's probably not a good idea, because you'll probably end up having all your requests being sent to SSDs, which is not going to be performant. The sweet spot for data tiering is about 20%. So if you have 20% of the most frequently accessed data or hard data, you can put that in memory, and then move the remaining 80% or not so frequently accessed data to the disk. If you were to stand up an ElastiCache cluster, say, with whatever nodes, and then completely fill up your memory as well as the SSDs, you have the potential to save up to 60% in costs compared to if you were to load the entire data set in memory. That's a lot of cost savings. Towards your right, you can see an example of our largest data tiering node. It's R6GD16XL. We have expanded the storage capacity from about 420 GB bytes to about 2 terabytes. One key point that I would like to make here is that data tiering is completely transparent to your application. It requires no application-level changes, and it's designed to have minimal performance impact. So if you were to stand up an ElastiCache cluster with this particular node type, R6GD16XL, and let's say you configure for about 500 nodes, you can scale to 1 petabyte in one single cluster. This is a quick comparison of our data tiering node with its closest non-data tiering node. So the biggest difference you're going to see here is the letter D, right? Yeah, D stands for disk. It's not just the letter D, it's the storage capacity. So if you look at the R6GD XL, we have expanded the capacity from about 26 GB bytes to about 125 GB bytes, right? From a pricing standpoint, data tiering nodes are slightly more expensive because they come with the fully managed data tiering software as part of the node. But they also provide you with 4.8x more capacity. So the real metric that you want to look at is the one right at the bottom, which is the price per GB byte per hour. With data tiering node, it's about 0.6 of a cent per GB byte per hour. That's about 60% in cost savings. So our data tiering nodes range from R6GD XL all the way to R6GD16XL. So this is a quick rundown of all the specs of our data tiering nodes. This information is available on our public website. I'm not going to go over everything line by line. You guys can access it. But the key metric I want you guys to focus on is the one on the right, right? No matter which data tiering node you guys use, XL all the way to 16XL, it is the same price per GB byte per hour, 0.6 of a cent. Now, the pricing here is based on US East region and on-demand pricing, right? You can further save on top of this if you were to use our reserved instances. If you have any sizing-related questions, please reach out to us, and then we can assist you further. We constantly work on expanding our support for data tiering nodes across all the regions in the globe. Since last year, we have added support for 4 new regions. We have supported regions in Montreal, we have regions in São Paulo, Paris, and Mumbai. Now, let's dive a little bit more deeper into data tiering. With data tiering, we talked about how ElastiCache constantly stores the last access times of all the items in memory. The way LRU algorithm works is that it works atomically at the item level on an all-or-nothing basis. So if you were to work with Redis, how many of you guys are actually familiar with, have some level of expertise in ElastiCache or Redis? Pretty much everyone, right? So if you have worked with hashes or sorted sets or some other complex data structures, so if you're accessing only certain attributes of a hash, that means you're accessing the entire hash. Data tiering, let's say your hash has not been touched for some time. Data tiering will then push the entire object to the disk. Later point of time, if you were to access only certain attributes of the hash, then data tiering engine will then push the entire item back into memory for access. So guaranteed that there's going to be a little bit of a performance impact, but keep in mind that it's a one-time performance hit to bring the item from SSDs back into memory. Now, key point here also is that all the keys will always, all the time, be in memory. It's only the value portion of the key that gets paged from memory to the disk, back and forth. Also, there's an asynchronous communication between ElastiCache Redis and the data tiering engine. So this is designed to have an optimization for latencies. Also, I want to re-emphasize that data tiering does not require you to have any application-level code changes. Let's go down a little bit, one layer down, and take a look at a typical GET request flow for an ElastiCache data tiering cluster. A client will issue a GET request to Redis. Redis will first look up additional information about the key from an online dictionary to identify if the value portion of the key exists in memory or on the disk. If the value portion exists in memory, the standard request flow follows, right? You then return the object back to the client directly. No changes. It's easy. But if the value portion of the key exists on the disk, the client will then go into a blocked status. But all the other requests are still being processed. Redis will then spawn a new thread to bring the data from the disk back into memory. Once done, it will notify the main thread. The main thread will then unblock all the clients and then start executing the commands and send the results back to the client. Now let's double-click on the FlashCache, right? FlashCache is an append-only log structure that actually houses both the key and the value. But it also has a hash map that's in memory, which again indexes back into the append-only log structure. The hash structure that is in memory has a couple of entries, right? You have a hash of the key that points to a hash bucket. So this hash bucket has a bunch of keys and values. The offset is then will help you to go traverse this hash bucket into an individual key and a value. We also keep track of the log structure using a head and a tail pointers to make sure how it expands or shrinks. We did a lot of benchmarking for our data tiering clusters. We used a standard Redis benchmark, and we ran this workload for about 2 weeks using an R6 GD2XL. We loaded for about 400 million keys. The key size was about 16 bytes, 15 bytes, and the value was about 500 bytes. We had about 200 client connections, and the get-to-set ratio was about 4:1. We also wanted to make sure that we curate the workload such that at least 10% of the requests go to the disk. So from a performance standpoint, we did not notice any significant performance difference. The latency profile on your left, you can see that P99 was about 1.4 milliseconds, and then the average latency was about 820 microseconds. From a throughput standpoint, we were able to generate about 240,000 transactions per second. So if your application can tolerate such latency profiles and throughput, data tiering could be a good option for you guys. So now, if you want to really test your clusters, your workloads using data tiering, we have released 4 new metrics for data tiering. The 4 new metrics on your left, num items written to disk, num items read from disk, bytes written to disk, and bytes read from disk. All these metrics will help you gauge how much of IOPS your application is loading against your database. We also added 2 new dimensions to existing metrics. For instance, cur items and bytes used for cache, it's broken down now by memory and SSDs. So you could break down your monitoring to see where your data is between memory and SSDs. So a lot of our customers constantly monitor our data tiering clusters. And it's very important to look at the latencies. The metric towards your lower right, bytes written and read from disk, is very, very important in this particular aspect. So from a monitoring standpoint, if you take a look at that metric and then compare it with total amount of operations against your cluster, like total get and set operations against your cluster, if the ratio is high, that means that all of your requests or hot data requests are going to the disk, which means that it's time for maybe scaling out your clusters, adding extra memory capacity, because the hot data is now sitting on the disk. That's a key takeaway from here, is that you want to constantly monitor your items read or written from SSDs. Now, I want to close here and recap about what we discussed. And the key takeaway here is that with data tiering, we are now providing a new price performance option for our customers. It's the ability to expand the storage capacity much beyond just the memory. It's adding at least 4.8 times more capacity using the SSDs. Important point also is that this requires no application level changes. It's completely transparent, and it's designed to have minimal performance impact. It's now available in 13 AWS regions. With that, I'm going to turn this over to Itai to talk about our other in-memory database service and also the latest and the greatest features.
Thanks, Siva and Malik. I'm always excited to see our customers share their success stories. My name is Itai, and I'm the General Manager of in-memory databases at AWS. It's so cool to see the journey that Yahoo did and how they use data tiering to scale to a really massive scale with great performance at a low cost. And now I will briefly talk about a new service that we launched in 2021, MemoryDB. I'll briefly talk about it and then talk about the new features that we launched with ElastiCache this year. As you can see on the slide, MemoryDB for Redis already supports data tiering as well, so you can get the same kind of cost benefits that we talked about in this service as well. All right, so what is Amazon MemoryDB for Redis? It is the fastest, durable database that AWS offers today. It has microseconds read latencies, and it has a low single-digit millisecond write latencies. A single node can support up to 1.3 gigabyte per second read and about 100 megabyte per second write. It is compatible with Redis, which means that you can take advantage of all of the data structures that Redis has, all of the rich APIs with sets and sorted sets and lists and so on. And you can benefit from the rich Redis ecosystem with client libraries in over 50 languages. And you get to do that with durability. Like all of our services, it is fully managed. We do all of the heavy lifting, so you don't have to worry about it and focus on what matters for you most, which is your business. So we do the installation, configuration, monitoring, patching, snapshots, and so on. It is highly scalable. On a single cluster, you can scale up to 500 nodes. And if you use the configuration that we recommend, which is a highly available configuration, 1 replica per shard, then you can scale to 128 terabytes of data, all in memory, with in-memory speed. It provides durability. So one of the key innovations that we built in MemoryDB is using a multi-availability zone transactional log. So the way it works is that every write is acknowledged after getting written to 3 copies in 2 different availability zones. It is backed up by the same technology that's been used by S3 and by Amazon.com ordering data. It is highly available. If you use 1 replica per shard, we take care of all of the monitoring and then failover when the primary node fails, promoting a replica to primary, and then replacing replicas. And it has security and compliance. It has features like encryption in transit, encryption at rest. It has role-based access control for authorization and authentication. And it has compliance with HIPAA eligibility, and it has PCI DSS and SOC. You can try it for free. We have a 2-month free trial, and you can try it on starting today. So who uses MemoryDB for Redis? So we have a lot of different business segments that use MemoryDB for Redis. We have web and mobile customers using it for user content data store, for session management, for chat and message queues, and for geospatial indexing. They can benefit from the rich Redis data structures. For example, for session management, you can use the hash data structure, and it makes it really easy to implement session store. Or you can use the list data structure in order to implement lists and queues and message queues. You can also use the geospatial commands to do geospatial indexing. We have customers in the retail business doing customer profiles, inventory tracking, and fulfillment. We have a lot of customers in the gaming industry. They too use the session management, and they also use the Redis data structure, the sorted set, for leaderboards. In fact, using the Redis sorted set data structure is one of the most common solutions today to implement leaderboards. We have customers in the banking and finance using it for fraud detection and for user transactions. We have several customers in the media and entertainment. In fact, Netflix was one of the first MemoryDB customers. And we have customers in the IoT using it for streaming device data and operational insights. If you want to learn more about it and more about MemoryDB, you can check out the session that we have tomorrow with Samsung SmartThings. It's an IoT application, and then that is DAT321. So that is happening tomorrow. So to quickly summarize the in-memory databases in the eye of durability. So on the far left side, you have Amazon ElastiCache for Memcached. It is super fast with microsecond reads, microsecond writes. It supports the popular Memcached API. But if a node goes down, you lose the data on this node. So if you have a 10-node cluster, you lost the node, you lost 10% of your cache. It is really useful primarily for caching and ephemeral data. In the middle, we have ElastiCache for Redis, which has microsecond reads and microsecond write latencies. It is semi-durable because you have snapshot and restore. And also, when you use the highly available configuration with 1 replica, we will do asynchronous replication between the primary and the replica. And if the primary fails, we'll do a failover to the replica. Because the replication is asynchronous, you will lose that tail end of the writes. So you will have some minimal data loss whenever there is a failover. And in a very unlikely and extreme case, you might lose more data. And the reason is because at the end of the day, it's stored all in memory and not on a durable media. ElastiCache for Redis is also the most popular solution that we have because of its rich data structure, all the features that we have, and its latencies. If you want to go all the way to the right, we have the most durable solution we have, which is MemoryDB for Redis. And as I said earlier, it was designed, like all of our databases, for zero data loss. And it has the multi-availabilities on transactional log to support that kind of, what we said, 3 copies and at least 2 different availability zones for every write request. MemoryDB has microsecond reads and low single-digit millisecond write latencies. So these are the different offers that we have today with in-memory databases. All right, so coming back to the main topic here, which is ElastiCache, and we'll talk about the new features that we launched this year with Amazon ElastiCache. So before I start, I want to highlight that all of these features are available to you at no additional cost. We launched a new and improved management console. It is available to you in the AWS console, and it simplifies the user experience when creating and managing ElastiCache clusters. Starting with our Memcached engine, we support Memcached 1.6.12, which has operational improvements, performance improvements, and better thread management. We launched encryption in transit in Memcached using TLS 1.2. Similar to all of the security features that we have for our Redis offering, our Memcached customers also wanted to get this kind of security layer. So we built encryption in transit in the server side and also in the client side in 2 clients that we provide, the Java client and the PHP client. And you can find those clients on our website, in the AWS console, and on GitHub. Launching support for Memcached encryption paved the way to get it certified with FedRAMP and HIPAA eligible, and we will continue to work to get it certified with the same certifications we have for Redis, including PCI DSS and SOC. We launched IPv6 support. Some of our largest customers achieved such a massive scale that they needed support for IPv6. We supported both for Redis and for Memcached. And we support it in 2 modes. One is IPv6 only mode, which means that the cluster will accept only IPv6 connections. And we support it in a dual mode, where the cluster will accept both IPv6 and IPv4 connections. Back in the beginning of the year, we launched the Redis log delivery through Kinesis Data Firehose and CloudWatch logs. This is for all of you who are power users, who would like to have this additional transparency and visibility in what's happening inside the engine. So how can you use it? You can use it to troubleshoot problems. For example, let's say you have a slow command. So what is a slow command in Redis? Redis is super fast. I just said it has microsecond reads and writes. So for example, you also have a lot of functionality in Redis. You can have the keys command that fetches all of the keys in Redis. And when you have millions of keys, this could be pretty expensive. Or if you have a very large hash set or a sorted set and you want to fetch the entire thing, that could be expensive. So you can use this feature to do this kind of troubleshooting. And I would like to highlight that this feature is only for operational purposes. We, by design, omit all of the customer data from these logs for your protection. We launched support for native JSON for our Redis offering. So now you can store, fetch, and update JSON objects in your Redis cluster without the needing to do complex serialization and deserialization work. You can fetch a portion of the JSON object, and you also store a portion of the JSON object. And putting this on something like ElastiCache for Redis, which has microsecond reads and write latencies, is super powerful and super efficient. We also support the JSON path in order to do searches within the JSON object. So this is a really cool tool that you can get really fast JSON and really great latencies with the very popular JSON format. We launched support for AWS Private Link. So what is Private Link? Private Link provides private connectivity between the AWS services, and the VPCs, so the traffic does not go through the public internet. With a VPC interface endpoint, you can connect between your application inside the VPCs to ElastiCache APIs. And you can also connect through VPC peering to other VPCs, and also from on-premises using AWS VPN and AWS Direct Connect. We launched Redis 7. Redis 7 is the latest and greatest Redis version out there. It has key innovations like the access control is v2, like the Redis functions, and the sharded PubSub that scales very well with the cluster mode enabled configuration. ElastiCache supports up to 500 nodes in a single cluster. And we have a lot of customers using PubSub, a very popular feature, so we really needed something that scales. I'm also proud to say that my team has worked together with the open source community and that we contributed the sharded PubSub and the ACL v2 to Redis open source. So you can find it in Redis 7 open source as well. And then the last feature that we released this year is the IAM authentication for Redis. IAM is identity and access management. Up until we launched this feature, you were able to do authentication using the native Redis system. Now you can use the IAM authentication system to associate IAM roles and IAM users with ElastiCache for Redis users. This gives you a very powerful solution because you can use the role-based access control for authorization, and you can use IAM for authentication. And then this aligns well with how you do identity management and authentication across all of your application in AWS. So always excited to talk about the features. We're going to have tons of new features coming up, so just stay tuned. A quick word about global availability. As you may know, AWS is available in 30 regions across the world with 96 availability zones. Just this year, we launched 4 new regions in Spain, in Dubai, in Hyderabad, and Switzerland. ElastiCache is a foundational service, and it exists in all of AWS regions, and it will be part of every new region that we launch. So you can take this kind of dependency on ElastiCache when you plan for your global scale. So that's pretty much it. We really thank you for your patience. We talked about the journey that Yahoo did and how they use data tiering to achieve massive scale with great performance at a low cost. We also talked about MemoryDB and the new features that we launched with ElastiCache. Before we go into questions, you can scan this barcode to get access to webinars, videos, blogs, white papers, and so on, and everything else that you need to get started with ElastiCache. So thank you so much. Please complete the survey. We really appreciate your kind word. And with that, we'll take questions.